as we continue to learn more about factoring, and we're going to factor by grouping in the next lesson. I want to review a little bit of our multiplying binomials together, FOIL method. Just to review, when you're multiplying two binomials together, you need to take each term and multiply it by both terms in the other set of parentheses. So 3x times 2x becomes our 6x squared, and 3x times negative 4y would be a negative 12xy. Then we take and distribute the y, and we get a positive 2xy, and then a negative 4y squared. We look for terms that like terms, and we get the two middle terms for both of the xy types. So we get 6x squared minus 10xy minus 4y squared. And that's our answer there. Over here we have x minus 1 squared. Make sure you remember that that is x minus 1 times x minus 1. Go through your FOIL again. X squared minus 1x minus 1x again. And then negative 1 times negative 1 is a positive 1. So we get x squared minus 2x plus 1. Okay, that was the review. Now, let's go back to problem number 10. Now what we're going to try to do is to factor by grouping. So we have four terms here. 1, 2, 3, 4. And we're going to group them so that the groups, we're going to pair them up so that both pairs have something in common. So these two guys, these first two terms both have an x, but there's nothing in common between the last two terms. So let's try a different combination. What if we tried the first two terms, the first two terms, they both have an x in common, and the second and fourth term both have a 2 in common. So we're going to rearrange this and make it x squared plus x plus a 2x plus 2. Then I'm going to look at those two terms, and I'm going to pull out an x just from those two terms. And then I'm going to add to that what I get when I divide out a 2 from both of those terms. So what this is now I have both of these two terms now have an x plus 1 in common. So I can actually pull out an x plus 1 from both of those, and I get x plus 2 from here and here. Because it was x plus 1 times x, which is here, and x plus 1 times 2, which was over here. Okay. Let's look at a different one. So this is what you get when you factor by grouping. Let's try over here. What two pairs have something in common? Well, there's a 3, and there's a factor of 3 there. There's a 4 and 2, so 2 goes into both of those evenly. So I'm going to pair these two up. I'll write a 6y squared plus 3y. And then I'll write these two next. Minus 4y minus 2. Okay? So, looking at these first two terms, what common factor do I have between those two terms? Both of them have a 3 in common. Both of them have a y. So I can pull out a 3y from both of those. 6y squared divided by 3y would be 2y. 3y divided by 3y would be 1 plus 1. What am I going to pull out of these two terms? They have a 2 in common. In fact, I can actually pull out a negative 2 from both of those. And I get a positive 2y plus 1. Again, I have ended up, almost by magic, that both of those add a factor of 2y plus 1. So these two terms now both have a 2y plus 1 as a common factor. I'll pull 2y plus 1 out, then this is left with a 3y and a minus 2. 3y and minus 2. Let's look at number 12. What terms have something in common? The 12ax has a lot in common with the 4ay. The 3wx has a w in common, at least, with the wy. So I'm going to rewrite it. 12ax plus the 4ay. I'm going to write those two first, followed by the 3wx plus the wy. So what, if I factor something out of those two, I can factor a 4 out and an a. Take a 4 and an a out of 12ax, and I'm left with 3x. Take a 4 and an a out of 4ay, I'm left with plus y. Over here, the only thing they have in common is a w. So plus w, and I'm left with 3, and the w cancels with x, plus, if we take the w out, I'm left with y again. So there it is, 3x plus y. So if I factor out a 3x plus y from this term and this term, if I divide this term by 3x plus y, I'm left with 4a, and if I divide this term by 3x plus y, I'm left with plus w. So that's factor. You have two things multiplied together. It's always a good idea to go back and check and FOIL this out. Check the 3x plus y times 4a plus w. Go through and FOIL this out. And make sure you end up with that in the end. They need to be equivalent. All right, let's try again. 14. What do they have in common? What are some pairs I can match up? Well, I could match up those two because they both have an a, but then these two have nothing in common. So let's try a different combination so that I can have two pairs and both of them have something in common. So what if I paired up these two, which both have x's in common, and these two, which both have y's in common? So xa plus x plus the ya plus y. Factor out the x from the first two terms, and get a plus 1. Factor out a y from the second two terms, and I still leave with an a plus 1. So then a plus 1 is a factor in both of these two terms, and when I factor it out, take an a plus 1 out of the first one, you get left with x. You take an a plus 1 out of the second one, you're left with y. And again, go back through and FOIL that and make sure you end up back where you started. Let's look here. Number 15, see what it has in common. These two both have 4's in common. These two both have d's in common. Any other combination, and one of them is going to have something in common, but the other pair won't. So we'll start with the d squared plus d. We'll rewrite the problem. Plus the 4d plus 4. Then factor out a d from the first two terms. Look at d plus 1. Over here, I'm going to factor out a 4 from both of those. Left with, again, d plus 1. Now, both of these terms have a d plus 1 in common. So if I factor out a d plus 1 from both terms, I'm left with d plus 4 as my other factor. And again, number 17. Let's see what has some things in common. These both have A, and these both have B. Or, if you look at the numbers, these both have 3's, and these both have 5B as a common. So let's try it as it is, and maybe we won't have to adjust and rearrange the terms. If we take these first terms, we take a 5B out, we're left with A plus 2B. If we take a 3 out of that second two terms, we're left with A plus 2B as well. So then both of them have an A plus 2B in common that I'll take out, and I'm left with 5B plus 3. So that one I didn't have to rearrange. What about 18? 18 is a little tricky. I have an x squared and an x, another x, and a minus 1. So I kind of need to remember my difference of two squares, I think, and might help me with this one. Okay, so this one's tricky. I'm going to start out, what we're going to pair up is we're going to pair up the x squared and the negative 1. We're going to put x squared minus 1 minus x plus x. And here's why. This is a difference of two squares, which we learned in chapter 7. And that factors into x plus 1 times x minus 1. Over here, these two terms both have an x in common. So if I take an x out, I want to go back and rearrange these so put the negative 1 in the middle. Plus x minus x. And I take out an x from each one. I'm left with 1 minus 1 left, which turns out to be 0. And I don't know why I didn't see this sooner. I could have seen it right here, canceled it a lot earlier, and I would have been here way back earlier. X plus 1 times x minus 1. And as we progress through factoring, what we need to look at now is a way to solve for our variables. That's what this is all leading up to. So the fact we need to remember is the zero product. Anything, you have two things multiplied together to get 0, and you know that the product is 0. You have 5x times 4x minus 3, the product is 0. One of those two things has got to be 0 for you to get 0 as a product. So either 5x is equal to 0, or 4x minus 3 is equal to 0. So we're not having to go back and factor yet. We're just going to practice this. So if 5 times x is 0, divide both sides by 5, then x has to be 0. So that's one possible value of x that will make this problem come out right. Or, let's solve the other one. Add 3 to both sides. We're left with 4x is equal to 3. Divide by 4. And the other possible value is that x is equal to 3/4. Again, over here, same thing applies. We have two things multiplied together to get 0. So either 6b plus 3 is equal to 0, or 12d is equal to 0. One of those two things, if one of those two things is 0, then the whole thing becomes 0. So what are the two possible values of d? We'll have to solve each equation separately. 6d would be equal to -3. That's 6. d would be equal to -1/2. That's one way to get 0. Or divide by 12. Or simply let d be equal to 0. If you put d to 0, you get whatever times 12 times 0 will be 0. Or if you put d and let d be a -1/2, and everything in here becomes 0, which forces everything to 0 out. So here's where that leads us, is if we get everything to one side and set it equal to 0, we add 2g to both sides, we get g squared plus 2g. Those cancel, and that's equal to 0. Now, if we use our factoring skills that we've learned, we factor g out, because that's what they both have in common. We're left with g plus 2. That's equal to 0. Then we can use our zero product, and either g is equal to 0, or g plus 2 has to be equal to 0. So that's one of our possible solutions, or possible values of g. The other is, I subtract 2 from both sides, then g would be -2. So either if g is either one of these two values, then that'll cause those two values to be equal. It'll cause it to be equal to 0, which is equivalent to the previous equation. So, example 24, same thing. We're going to set it equal to 0, which means we're going to take everything off of one of the two sides. And that cancels that equal to 0. So I get 8h to the third minus 8h squared. What do they have in common? An 8h squared. That's their greatest common factor. You're left with h minus 1. So either 8h squared is equal to 0, or h minus 1 is equal to 0. That's the only way to get 0 as an answer when you're multiplying two things together. 8h squared divided by 8, you get 0, square root of h. H has either got to be 0 or add 1. H is positive 1. So our three possible values of h, and we get setting them equal to 0 and factoring, figure that out. All right, wraps that up.